Assalamualaikum warahmatullahi wabarakatuh. We are going to present about our control system fundamental BEA 2383 assignment. My name is Muhammad Nur Faiq bin AZIAN, and my matrix number is B082110152. And my other group members, Muhammad Raffiq bin Johar, B082110086, Ahmad Raffiq NASRULLAH bin RAMLI, B082110408, and last HAZEEM Faeez bin MUSTAPHA, B082110443.
Assalamualaikum, my name is Muhammad Raffiq bin Johar. I will continue on the introduction part of the slide presentation. The assignment focused on analyzing and controlling a second order system in engineering application using MATLAB. The project involved a group of 4 students collaborating to understand the chosen application, identify the control mechanism, create a block diagram representation, derive the system transfer function, and analyze its response through simulation. Key tasks include explaining the application's relevance, drawing the block diagram, calculating performance metrics, simulating the system response, assessing stability, and determining steady-state error for different inputs. The project aims to provide practical experience in system modeling, control analysis, and MATLAB simulation, fostering collaboration, critical thinking, and problem-solving skills for tackling complex engineering challenges. Alright, we will go through the explanation. First, control system in engineering. Control system consists of interconnected elements like sensors, actuators, controllers, and feedback mechanisms. Their primary objective is to maintain stability, achieve desired performance, and track or regulate the system output. Second, types of control system. Open loop control system, simple but lack of robustness, relying solely on input commands. Closed loop feedback control system utilize feedback to continuously adjust control actions, providing improved stability and accuracy. Third, DC motors in manipulators. Manipulators are used in industrial automation, robotic arms, and assembly lines for precise positioning and control movements. DC motors act as primary actuators, receiving control signals and feedback from positioning sensor to achieve accurate positioning and trajectory tracking. Lastly, DC motors in servo mechanism. Servo mechanisms are vital in aerospace, robotics, and manufacturing for precise control of position, speed, and torque. DC motors work with feedback sensors and control algorithms to accurately track desired in trajectories or maintain speed and torque levels. Alright, now is the block diagram. You got the input and the controllers and the converter, DC motor, and load. Also, you got the feedback.
For the transfer function, we use GS equal to 1 over S power of 2 plus X times S plus 100. Describes a dynamic system in control systems engineering. The numerator of the transfer function is 1, indicating a direct relationship between the output and input signals. The denominator, S squared plus 8 times S plus 100, represents the system's characteristics and indicates a second order system. The coefficient 1, 8, and 100 in the denominator determine the system's behavior and stability. The coefficient of S squared represents the damping ratio, affecting the system's response to disturbance. The coefficient of S is related to the system's natural frequency, influencing the system's response speed. The constant term, 100, represents the system's static gain, determining amplification or attenuation in steady state. The transfer function helps analyze stability and response by examining the system's poles, determining by the quadratic equation's roots. Engineers can evaluate the system's frequency response by substituting complex numbers into the transfer function. The transfer function assists in studying the transient response, observing the system's behavior when a new input signal is applied. By analyzing coefficients and roots, engineers can determine damping ratio, natural frequency, and static gain. Understanding stability, frequency response, and transient response allows engineers to design effective control strategies. In summary, the transfer function Gs equal to 1 over s squared plus 8 times s plus 100 provides important information about a second-order dynamic system's behavior. Analysis of the coefficients and roots helps determine stability, natural frequency, damping ratio, and static gain. This knowledge is crucial for designing control strategies and ensuring desired system behavior. So as we can see, we use the simulation on MATLAB. On MATLAB command window, we enter sys equal to tf, open the bracket 1, comma, open the bracket again, 1 space 8 space 100, close the bracket, and semicolon. And then the step info, open the bracket, sys, close the bracket, to get the rise time, transient time, settling mean, settling max, overshoot, undershoot, peak and peak time value. So for the rise time, we got the value of 0.1465, transient time 0.8409, settling time 0.8409, settling mean 0.0091, settling max 0.0125, overshoot 25.3741, undershoot 0, peak 0.0125, and peak time 0.3454. And we type the step, open the bracket, sys, close the bracket, semicolon, to get the step response graph. So as we can see, we got the underdamped graph, right? So the underdamped graph provides engineers with insights into system performance and stability. Excessive oscillations and a prolonged settling time can indicate instability or undesirable behavior. Therefore, engineers may need to adjust the system's parameters such as the damping ratio to achieve the desired response. It is important to note that the underdamped graph represents the system's transient response, which is the behavior during the initial period after applying a new input signal. Once the transient response settles, the system should ideally reach a steady-state response, where the output stabilizes at the desired value without oscillations. In summary, an underdamped graph in control systems represents a system's response characterized by transient overshoot and oscillations. The magnitude of overshoot, settling time, and oscillations depend on the system's damping ratio. Analyzing the underdamped graph helps engineers assess system stability and performance, enabling them to make adjustments to achieve desired behavior. Alright. Furthermore, we also use Simulink to get the graph of step response. And on the Simulink, we use step input, summation for the feedback, and transfer function. And last is scope. So by simply double click on the scope and click on the play button, we got the step response graph.
Assalamualaikum. My name is Raffiq RAMLI. Now my turn to present about the calculation result. So for our transfer function that we get in this assignment is 1 over s squared plus 8s plus 100. First, we need to find the peak time, which is the formula is pi over 10 square root 1 minus 0.4 squared equal to 0.3428 seconds. Then we must calculate the settling time, which the formula is 4 over 4 times 10 equal to 0.1 second. Next, the rise time. The formula is 2.16 times 0.4 plus 0.6 divided by 10, which I get 0.1464 second. And the last one is the percentage of the overshoot. So the percentage I got the 25.38%. Now I will talk about the discussion for this assignment. Number one is a second order transfer function is a mathematical representation of a dynamic system that has two poles in its denominator. It is commonly used to describe a wide range of physical systems in engineering, such as mechanical, electrical, and control systems. The transfer function that we get from the simulation is GS equal to 1 over S squared plus 8S plus 100 that we use in simulation using MATLAB. Then, calculated the result from the transfer function obtained as to make a comparison between simulation in MATLAB and calculated value. Next, for the graph shows the underdamped response that indicate the system is unstable, which is a type of system behavior exhibited by second order systems when the damping ratio is less than 1. And for the last, when an underdamped system is subject to an input or disturbance, the system response initially exhibits overshoots. This means that the output of the system temporarily exceeds the desired or final value. The amount of overshoot depends on the specific parameter of the system and the initial condition. That's all from me. Thank you. Now I will explain about the analysis about the results comparison between the calculation and the simulation. So for the peak time, for the calculation we got 0.3428 seconds, while the simulation is 0.3454 seconds. Next, for the settling time, I got 0.1 second for the calculation and 0.8409 second for the simulation. Next, rise time, I got 0.1464 second for the calculation and 0.1465 second for the simulation. Lastly, for the percentage overshoot, I got 25.68% for the calculation, and for the simulation is 25.37%. That's all from me. Thank you.
Okay, for the last part is conclusion of this project. In conclusion, control systems are crucial in engineering for precise manipulation and accurate positioning. DC motor systems play a vital role in manipulators through mechanism and positioning system, offering versatility and precise control. Closed-loop control systems with feedback provide improved stability and accuracy compared to open-loop systems. And next, underdamped graph in control system visually represent a system response and offer valuable insight into stability and performance, allowing engineers to optimize and adjust for desired system behavior. Overall, understanding and implementing control system with DC motor systems enable efficient and reliable operation in various applications. Okay, that's all from my group.